Hello guys, so this is question number 10 of engineering thermodynamics that appeared in civil services mains examination 2002 and it was of 20 marks. So let us see the question. Give the Kelvin Planck statement and Clausius statement of second law of thermodynamics and show that violation of either statement implies violation of other. A Carnot engine 1 operates between reservoirs at temperatures of 2000 Kelvin and T Kelvin. Another Carnot engine 2 operates between the reservoir at T Kelvin and 300 Kelvin. If both the engines have the same efficiency, determine the value of T. So let us solve this question. Now first of all, let us write the statements of Kelvin Planck and Clausius statement. So Kelvin Planck statement. It is impossible for a heat engine working on a cycle to produce work continuously by exchanging heat with only one reservoir. Now, second statement of Clausius, that is Clausius statement is it is impossible to construct a device which will produce no effect other than transfer heat from a cooler body to a hotter body. So Kelvin Planck statements deal with working on a cycle that uh, a cycle cannot work with only one reservoir. While the Clausius statement says that there cannot be no device which produces or does the work of heat transfer from a cooler body to a hotter body without any work being done on it. So these are the two statements. Now for equivalence of these two statements, let us make some diagrams. Let us make a diagram, this one. So it is a hot reservoir at a temperature T1. Now heat Q1 is given to a heat engine. Now no work is performed on it, so work is 0, and this produces a work that is equal to Q1. Why? because Q2 is equals to 0. So this is according to the Kelvin Planck statement we have made this device. Now another heat pump that is working between this sink at a temperature T2. Its sole work is to take heat Q2 from temperature T2, that is the sink, that is a higher temperature body, sorry, colder temperature body, to a reservoir that is a higher temperature body. So net heat that is given to temperature reservoir T1 is Q1 plus Q2. Now consider a heat pump as shown here. If this heat pump is operated along with a heat engine as shown in the figure, the net work net done is equals to Q1 minus Q2, while heat is being exchanged only with the sink. So net work done is equals to Q1 minus Q2. Now this is the violation of Kelvin Planck's statement. And now consider this heat engine as shown in this figure. Now this violates the Kelvin Planck statement. The heat engine is used to power a heat pump. Now that transfer heat Q2 from sink and pumps heat Q1 plus Q2 to source. In effect, this heat pump transfers heat Q2 from sink to source without any external work, because work done is 0. Hence, which is violating the clause's statement. So we can prove like this. Now according to question, another thing that is given in the question is source 1 at a temperature of 2000 Kelvin. Now this is a heat engine 1 that is working in the source 2, that is at T Kelvin, and this is heat engine 2, and this is sink at 300 Kelvin. Now for this heat engine, efficiency of 1 is given as 1 minus source temperature, that is T, divided by 2000, and the efficiency for this heat engine 2 is given as 1 minus sink temperature, that is 300, divided by source temperature, that is T. Now we know that the efficiency of the two heat engines will be same. So efficiency 1 is equals to efficiency 2. Hence 1 minus T divided by 2000 is equals to 1 minus 300 divided by T. By solving this, we can get T is equals to root of 300 into 2000, which comes out to be 774.6 Kelvin. So with this we can make a short trick. If the two temperatures of source and sink are given, and in between them two heat engines work with a source temperature T, we can find out the source temperature T as root of T source, that is source 1, into T sink, that is T sink 2. So this is a short thing, and this could be asked in some other descriptive questions. So this question is solved. Thanks for watching.